We're going to be doing the law of sines today, and I think we're also going to be doing a little bit of area of a triangle using the proper formula. This whole unit is straight from geometry, right? It involves some trig because there's sine, cosine, tangent, but your triangles are not really right triangles. We're going to be looking at oblique triangles. So that's kind of a unique word. All that it means, if it's an oblique triangle, all we're saying is it's not a right triangle. So if you think about it, classifying triangles by angles, there's really three ways we can do that. What are the three types of triangles by angles? There's obtuse. Nope. There's an obtuse triangle that has an obtuse angle. There's an acute triangle and a right triangle. Right? Those are the three different types. So oblique is just one word to mean it's acute or obtuse. It's not right. Okay? So that's what we're looking at there. Solving an oblique triangle means we're going to be finding all the missing sides and all the missing angles. Is the law of sines. For any oblique triangle, this is the relationship that holds. So when we're talking about an angle and its side, notice how this is the angle alpha. Opposite angle alpha is side A. Here's angle beta. Opposite angle beta is side B. And I never can remember, I think this is gamma. This is angle gamma. Opposite angle gamma is side C. Okay? It's not delta. Alpha, beta, delta, gamma. I'm pretty sure it's gamma. I'll look it up in a second. That way I'll sound intelligent for sixth period. This is when we can use the law of sines. If I know an angle, a side, and an angle in that order, if I know two angles and a side beside them, or if I know two sides and one angle. We'll now discuss the three cases. So case 1 and case 2, if it is angle, side, angle, or angle, angle, side, this is the case when the information we were given about the triangle includes two angles and one side. So you can see here what we were given. We were given two angles and a side. So then we've got to find all the missing parts of this triangle. So for me, if I know two angles, how easy is it to find the third angle? You just add them up and subtract them from 180. So this would be 180 minus 98 minus 43. That would be 141. That's 39 is the missing angle. Is everybody okay with that? Now, here's the way I look at it. Like they explain it with this angle, side, angle, or angle, angle, side. I think of it like this. I can only use the law of sines if I know an angle and its opposite side. So before I knew this angle, like you see how I knew this angle but I didn't know the opposite side? I knew this angle but I didn't know the opposite side. Okay, but then once I discover this angle and I know the opposite side, that's the time I know I can use law of sines. When I know an angle and its opposite side. Okay, law of sines. So here we go. I always start with the ratio that I know. So if I've got sine of 39 degrees over the side opposite is 22. Is equal to, you can. Yeah, exactly. Sine of 98 over A. Just pick the other one. For law of sines, it doesn't matter which one you pick. You could pick in any order. Law of cosines, that's not true. We'll get there when we get there. So anyways, what do I have? I have a proportion with one unknown. I have a fraction equal to a fraction. Well, hopefully that's right up our alley. I've been doing that all year. That's my go-to. Fraction equal to a fraction. Cross multiply. So I've got a times sine of 39 equals 22 sine of 98. Now solve for a. A is being multiplied by sine 39, so I divide by sine 39. So we're just going to type that in. Make sure it's in degrees. Mode, degree. Oh my gosh, quit. Fraction 22 sine 98 over sine 39. I found A to be 34.618. Any questions there? Now, to find the other side, we've got to do it again. Here is my kicker, though. I just found this side, and I just rounded the answer, right? So I don't want to use this side again. I would rather go back and use the given side with the given angle. So I'm going to pick this rate again and set it up with the other angle. So I'm basically just going to have the proportion that Lydia said earlier. Sine of 39 over 22 equals sine of 43 over C. Everyone see what to do from here? So it's going to be 22 sine of 43. And I had to teach this to my Algebra 1 class. Do you guys know how to copy and paste what you just typed in on this calculator? I don't know if I've ever told you guys how to do that. Instead of having to type it all out again, you can go up to that, just tab up to that equation and click enter. It's going to copy and paste it in because you're essentially fixing to type in 22 sine 43 over sine 39, right? I'm just changing that angle. So if you go highlight the thing you just typed in and click enter, it'll paste it in and you can go change the angle. Do you understand what I'm saying, or do I need to show that on? Okay, so C equals 23.842. So let's clear this up first. If I know two sides of a triangle, why can I not use the Pythagorean theorem? Because it's not a right triangle. The Pythagorean theorem is only for a right triangle. But because it's not a right triangle, I can't find that third side. So I don't have a pair that I can look for. So when this happens, when I know two sides and an angle that's not between the two sides, right, side-side angle, then this is called the ambiguous, there's the word, ambiguous. I about said ambiguity. It's the wrong part of speech. Ambiguous case. You'll never hear me use that word again. All right. Essentially what it means is sometimes there can be no solution. Sometimes there's just one solution. Sometimes there are two solutions. And we have to assume that there's two solutions every time when we solve it. So let's look at an example of this and see what that's going to look like. So notice the triangle's not drawn for us. Why is the triangle not drawn for us? Well, this is because there are actually two different triangles that can be formed. So let's draw this situation out. I can't do this just from looking at that. Okay, so let's say this is angle alpha. It's 80. Opposite alpha is A, and A is 120. Okay, so let's say this is side B. It's 121. So this is angle beta. And this would be gamma and C. You technically can, but you want to rotate it where it's up in this direction. Because I'm fixing to show you why we're having to do it this way. Let me draw it, because I'm not doing it. Let me draw it. So this could be what the triangle looks like. Or imagine, pretend like it's like a, I don't know, pin the tail on the donkey. You don't know what that pin the tail on the donkey is? I got a pin up here holding this point, this 120. Technically, this side, if it could freely swing, it could be over here and still be 120. I don't know which one it is. So either angle gamma could be obtuse, bigger than 90, or it could be a very small angle to fit this side. You see the, basically like a swinging side. And we don't know for sure when we're given this case which of those it is. So, I did a bad job drawing it. This could still be 121. This could still be 120. And then this would be 80. This would be beta. This would be gamma. And this would be C. So now, I know one rate for sure. Sine of 80 over 120 equals I have to find beta next, right? Because I can't do C or gamma because those are both unknown. So I have to choose angle beta and side B. So sine beta and 121. Is it okay what I've done so far? I know I'm trying to give myself space. I cross multiplied. To get to here. Now I've got 120 sine beta. So I divide by 120. So that leaves me with sine beta equals that garbage. 121 sine 80 over 120. Have I found beta yet though? No, beta is not isolated. Right now we're taking the sine of beta. So to get beta by itself, I must do inverse sine. So in order to get beta isolated, I must take an inverse sine of both sides. Here is where the two possible triangles can come into play. Because, let's talk about this very quickly before we calculate it. Inverse sine is defined for what quadrants? 1 and 4. Whether it's positive or negative. This ratio is going to be positive. So it's going to spit out an angle in the first quadrant. So then the question becomes, where else is the ratio of sine positive? In the first and second. In the second quadrant, we could rotate an angle that still could be in a triangle and still get a positive ratio. So like 100 degrees is in the second quadrant, but I could still form a valid triangle with that. So basically, if it spits out 80 at me, then it could be 80 in the first or an 80 in the second, which is 100 total. And 100 can be an angle in a triangle. You follow that? That's where that second case comes in. It still fits in with the trig we've been doing, why there's a second case. But again, there's not always going to be two answers. So here, when I plug that in, what did I get as my angle? It was what? 83.22. Okay. So that means beta is 83.2. You said 224? Yes. Normally, I think on Canvas, they're going to make you round to 1 decimal for the angle. Or they may even do the nearest degree. I don't remember. So I'm just going to go 83.2 here. Okay. So now, using everything we just talked about, if I have 83.2 as a possibility in the first quadrant, what's the possibility for beta in the second quadrant? 96.8. Does everyone know how to get that answer? We got, tell me the number again. Is everyone okay with finding 83.2 as our answer? So how could I get 83.2 in the second quadrant? Well, this would need to be 83.2, which means I've rotated 180 minus 83.2. That's the same kind of logic that we did on the last test, and I saw those tests. So, all right, so 180 minus 83.2 means this angle could be 96.8. So this case could definitely happen, right? Now I've got to figure out, could this one happen? So add those together. What's 80 plus 96.8? So is there still an angle that I could get here to make the triangle add to be 180? So then both cases are valid, right? Sometimes when you get here, you're going to get an angle that, when I combine these two, it's over 180 already, which means that triangle's out. But because we didn't get that in this case, then I know that the missing side here is, we'll get there in just a second, okay? So the other option is beta could be 96.8. Any questions so far? Okay, from here, like, notice I'm not using the terminology like opposite, hypotenuse, adjacent. Like, none of that's out. I'm just strictly using these formulas for the law of sine that were discovered using right triangles. But they apply for all triangles. These ratios apply for all triangles. the sine alpha over A equals sine beta over B, sine gamma over C. It's for any triangle.
I guess it's just the quadrants that's confusing me about it, but I get it. It's okay.
It's all about, because I chose to take inverse sine. Inverse sine is only defined for quadrants 1 and 4. But in actuality, the ratio being positive for sine could put it in 1 or 2. Because all students take calculus.
No, I get that part. I understand why it's in quadrants 1 and 2. Never mind, I'm sorry.
Ask it again.
I don't understand how we have these obtuse and acute triangles in the unit circle.
We're not in the unit circle anymore.
Talk about quadrants.
I am. Because I'm using sine and cosine,
Okay.
which are right triangle operations.
Okay. Okay, that's good enough for me.
Okay. So, let's solve this triangle first. I know 2 angles. I can find the third angle. 16.8. And now because I know that angle, I can find the opposite side. Again, I would still use this rate, the one that was given to me. Don't go with the one that I rounded to find 83.2. Use the rate that was given. So sine 80 over 120 equals sine of 16.8 over C. Right at the top of the mountain.
Those are right in front of the red lights, right?
Just read that?
Those
Cross multiply. Now this time C is out front. C is being multiplied by sine of 80. So I can divide by sine of 80. And I'm just typing this in my calculator. 120 sine 16.8 over sine 80. I have an answer.
35.21 million.
Do I have a second? Somebody else agree with that? Here we go. So in triangle 1, these would be my answers. Beta 83.2, gamma 16.8, side C 35.219. That's a solution set. A second solution set can be found in this triangle. So I've got to do this same process again in a different triangle. So if beta is 96.8 and alpha is 80, add them up, subtract from 180 to find gamma, which was 3.2. So that leaves me with sine of, what's the one I was given? Sine of 80 over 120 equals sine of 3.2 over C. And it's the same process. Cross multiply. C sine 80 equals 120 sine 3.2. Divide by sine 80. So C equals 6.801. Have a second. And so this is a second solution set where beta is 96.8 gamma is 3.2, and C is 6.801. Questions?
Can you explain like the whole, like the different triangles? Like how you said that there's a pinpoint or whatever?
Uh-huh.
Yeah, I don't understand that.
Okay, so let me draw this one out. So if alpha is 80, the side opposite 80 is 100. So now if beta is 10, sorry, not beta. If B is 10, and I'm looking for beta, so this would be gamma and C. You can see we set it up just like before. Sine of 80 over 100 equals sine of beta, I don't know, over 10. Am I going too fast?
Yes.
It's all about, remember, opposite alpha is A, opposite beta is B, gamma is C. So I just drew a scenario that fit that criteria, and then I'm just using the law of sines that we've just been doing before. Is everyone okay here? Same process, cross multiply. 100 sine beta equals 10 sine 80. Divide by 100. So sine beta equals that garbage. So I'm going to take the inverse sine of both sides. So if I do the inverse sine of 10 sine 80 over 100, what did you guys get for beta? 0.7? 5.7? Do I have a second? So, this is 5.7. That's a possibility for beta. But remember, whenever we do inverse sine, we always have to think this could be in the second quadrant. Just to get the positive ratio. So how could I get a reference angle? Right now I have 5.7 in the first quadrant. So how could I get 5.7 in the second quadrant? I would have to rotate 180 minus 5.7 to back up, which would be 174.3. Can't work, because if beta was 174.3 and I already know alpha is 80, that's over 180. So that means there's not two solutions this time. There'll only be one. Does that make enough sense as to why? So now then, I have to do all that same process, but just with one triangle. I don't have to worry about a second triangle. So I can find gamma, because they have to add to be 180. That's going to be 94.3. Is that right? For gamma. And then I would find C. So again, use the rate that you know. Sine 80 over 100 equals sine of 94.3 over 5.7. Okay, to go a little quicker here.
Why is it not C?
It should be C. So that's going to be C sine 80 equals 100 sine 94.3. That looks awful. divide by sine 80. So C equals 101.257. Do I have a second? Okay, so I kind of talked a little bit yesterday about the area formula. And I see I don't have my screen pulled up. And so again, if we have time, I can go through where the area formula comes from. But you really don't have to know that. All you need to know is I need to have two sides and the angle between them. Or another way to think of it is side, angle, side. Right? If I know two sides and the angle between them, I can find the area. So that's why there are three different formulas here. But they're all just saying the same thing. If you know B and C, then you need the angle between them, which is A. So it's 1/2 BC sine A. Or if you know A and C, the angle between them is beta. And if you know A and B, the angle between them is gamma. But it's all those formulas we talked about yesterday, so no big thing. Here is an example where we need to find the area when we're given everything we need to know. So you don't have to draw a picture to do these, but I would, just because I tend to get a little confused and trip over myself if I don't write it out. So I know 42 degrees is beta, so opposite beta is B, which means another side needs to be A, so A could be here for alpha, and then that means if C is 3.4, this is gamma, right? I don't have to find any of these three things. I just more practice labeling. Notice how I know two sides and the angle between them, right? That's what I'm given. So in order to find the area is equal to 1/2. We multiply the two sides together. 7.2 times 3.4 times the sine of the angle between them, which this time is 42. So in this problem, I have one unknown. It's the area, and it's already isolated. So I just plug the rest of it into my calculator. So it would be 0.5 times 7.2 times 3.4 times, make sure in degrees I am, 3.4 times sine of 42. When I do all that, I find the area is 8.190, and that would be square feet. Any questions when that's our case? Just straight plugging in. So you can see here, they give me the area, they give me two sides, and they ask me to find the angle between those two sides. So again, I'm just going to plug into that formula. So the area, this time I know it, is 226.89 equals 1/2 times multiply the sides, 36 times 26 times sine of theta. And now we need to isolate theta. So theta is not by itself because we're taking sine of it, and it's being multiplied by those three numbers. So let's divide by those three numbers. That'll make it cancel over here. Do the same to this side. 1/2 times 36 times 26. Okay, so in my calculator, let's see, I've got 226.89 over 0.5 times 36 times 26. I got 0.4848076923 for the first part. So we okay with that? You guys may not have, you guys may have done it all in one step. So I get sine of theta equals that number, which was, I'm just going to leave it in my calculator. I'm just going to round up here, 0.485. But now theta is not by itself because we're taking sine of theta. So the way I can get rid of a sine is an inverse sine. So I would take an inverse sine of this number and go in second sine, second answer. And I found that theta then must equal 28.9998, which would round up to 29 degrees. A communications tower is located at the top of a steep hill, as shown. The angle of inclination of the hill is 75 degrees. A guy wire is to be attached to the top of the tower and to the ground, 154 yards downhill from the base of the tower. Oh my gosh, this drawing's awful. The angle formed by the guy wire is 11 degrees. Find the length of the cable required for the guy wire. So we are looking for this length, right? That's the guy wire. Okay, let's see. What do we know? So we're looking for this side. Let's call it X. I know that's 11.
What I did was I added 11 plus 75 and then made a right triangle. And then the letter E.
Where's your right triangle?
I'll just make one.
I think you can do that on this problem. 154, 1175. The length of the guy wire. I've got the thing labeled that we're looking for. I'm trying to use the law of sines, but I don't have a pair. Like I don't have an angle and side opposite. So I'm going to have to find one of those somehow. But I ain't figured out how yet. Please be easier. Points A, B, and C are separated by a lake. To find the distance between them, a surveyor, I'm sorry, not A, B, and C. Points A and B are separated by a lake. To find the distance between them, a surveyor locates a point C on the land such that the angle of CAB is 54.8 degrees. Find the distance across the lake from A to B. So I'm looking for this. And this time I have a pair that I know. I know sine of 54.8 over 546 must be equal to. So ideally, I would like to use this side, right? But to use this side, I would need to know this angle. Well, can I find that angle? No, that's exactly right. I'm going to have to find B first. So this is going to be a two-part problem. I'm going to have to find B. Then once I know beta, then I'll know two angles. I can find the third angle, and then I can find that length. So you see, this is just like the law of sine problems we were doing yesterday. So let's find beta. So sine beta over 400. And I'm going to cross multiply. So I've got 546 sine beta equals 400 sine 54.8. And so it's going to be the inverse sine of a fraction, which is 400 sine 54.8 over 546. I got beta to be 36.8. Is everyone okay with that? Get that in your calculator. So now I can find angle C, which is gamma here, by doing 180 minus 36.8 minus 54.8, and I got 88.4. And so now we'll do the law of sines again. I'm going to keep that original rate that was given to me. That's going to be equal to sine of 88.4 over x, cross multiply x sine of 54.8 equals, I'm running out of room, 546 sine of 88.4. Then I've got to divide, so 546 times sine of 88.4 divided by sine of 54.8. So we're okay with that? If I don't write it all out, I'm running out of space. Do I need to go over it? I will, if I need to. Just isolating the variable. So x equals 667.920. What did they get? 667.928. I mean, I guess. In your answer should be accurate to 2 decimal places. I mean, we did it all right. It's all in rounding. It's why we're different than theirs. When we rounded to 36.8, they probably kept it as 36.77262482. Right? So if you keep as many decimal places as you can, then that's going to make, I mean, you can see the relationship. It's going to make this angle smaller by just a little. It's going to make this angle bigger by just a little, which means we're going to make this side bigger by just a little. That's why we're at 0.920, they're at 0.928. I mean, all that fits. So. Questions there? Bearing and nautical navigation. Bearing. When we describe the direction of travel with respect to the cardinal directions, which are northeast, south, and west, often a concept called bearing is used. An object's bearing is the angle it forms clockwise from the north. So I know that everything we've been doing with unit circles, we start at 0 here and then we rotate this direction. Well, whoever made this is not going for that. Right? But it's the same concept. They're starting 0 is due north, and then 90, 180, 270, 360. So, for example, a picture of an object traveling on a bearing of 115 degrees. Could you figure out what that would look like? 115 degrees. It would be in which quadrant? The fourth. And that would mean this angle would be 25. Right? Because it's 90 is due east, so 115 would be 25 more than that. All right, and then they give 315. 315 would put me in quadrant 2 normally, and we would have a reference angle of 45. So they give you all that information. I don't know if there's going to be problems like that on the test, or I mean on your, not test, on the homework. And so if I see N30E, that means we are 30 degrees east of north. So here's the way that I'm reading these. It's 30 degrees east of north. So if I had to draw that, this is north. And so if I'm 30 degrees east of that, that means this is 30. I want 30 east of north. Does that make enough sense? Alright. 45 west of south. So this is south. I'm going west. So 45 west of south will be there. And then 30 degrees north of west. So this would be due west. I need to go 30 degrees north of that. It was making a sense that we could piece together where we're talking about, hopefully. So Carl spies a potential Sasquatch nest at a bearing 12 degrees north of east. That's not where Carl is. We don't know where Carl is. Well, we kind of do. Okay, here's Carl. From him, 12 degrees north of east is a Sasquatch, which means due east would be here. He needs to go 12 north of that. So somewhere here is Sasquatch, S. Okay. And this is 12 degrees north of east. Radio's Jeff, who is 52. Oh, I did that backwards. I'll get there. Give me just a second. This is easy stuff. Hey, this is the first thing I'm going to give you a chance to say this is difficult. This is the first hard thing we've done all year. Okay, there's Sasquatch. This is. Look, you see how much trouble I'm having? I ain't had trouble yet. All right, this is tough. Okay, here we go. Yeah, we'd still be stuck here with the other one. It's 12 degrees east of north, not north of east. East of north, which means if this is due north, this is 12. Okay, 12 east of north. Radio's Jeff. Okay, where are you, Jeff? You are 52 degrees east of north from Carl. This is back to what I drew the first time. 52 degrees east of north from Carl. So, somewhere over here is Jeff. And he is 52 east of north. Okay, all right. From Jeff's position, the nest is 69 degrees west of south. Yeah, hold on. 69 west of south. So this is south. He would need to be, here's west. He would need to be at 69. Which see, that's where the Sasquatch needs to be from Jeff. So that means Jeff needs to be everything else I had was right. You're not the only one. 12. Here's Sasquatch. How could he be 12? That don't make any sense to me. 69 west of south. Alright, I'm done. You guys can do your, go for it. Work on canvas.
Okay, but how are you doing with the canvas?
We look at dance first.
Yeah, I'm gonna watch it. No, I'm done now. I ain't doing this.
Thanks. Wow.
Good luck.
Did you not say this is really, really easy?
Yeah. Law signs is easy. This part's not. I didn't know I was gonna be a pirate. I want to be a pirate.
Is that gonna be on the test? Oh,
Huh?
is that gonna be on the test?
I don't know. We'll look and see.
I have so many eraser things.
Yeah, there's a whole lesson of this, it's not what it
Come on, Camp. Say the day. Oh, it's not Camp. Go figure. This seems like one of his problems. It's a niblet problem.
Navigation. So this topic is called bearing. Example, here's nautical navigation. West, always get what you want. So what do then they use this example. And this example is exactly what I'm talking about. They call it bearing, but then they use nautical navigation. I wish they wouldn't do that. But
No kidding.
can't always get what you want. So, Carl spies a potential Sasquatch nest at a bearing of north 12 east, 12 degrees east of north.
There you go. I'm not the only one.
Radio
Thank you.
Jeff, who is at a bearing of 52 degrees east of north from Carl. From Jeff's position, the nest is at a bearing of 69 degrees west of south. And it tells us Jeff and Carl are 510 feet apart. Alright, draw a picture. Always draw a picture.
Yeah, I tried.
Let's let Carl be right here.
Okay.
And it tells us that
12.
there's a Sasquatch nest 12 degrees east of north.
Yeah, I had that.
Call that S,
Uh-huh.
Sasquatch.
Okay.
Radio's Jeff, who's on a bearing of 52 degrees east of north. And it says the nest is 69 degrees west of south. So that means Jeff's gotta be up here somewhere. Okay. So, if we draw a little coordinate plane, or a little
I tried that.
axes on each of these, we can form a triangle. Alright? It tells us that from Jeff's from Jeff's position, the nest is at a bearing of 69 degrees west to south. So this angle
Uh-huh.
right here,
Yeah, okay.
60
It is gonna be that hard. I mean, that's what I had. It was gonna be outside of the triangle. Okay.
Jeff is at a bearing of 52
Should've
degrees
just kept going.
east of north from Carl's position. So this angle
Uh-huh.
is 52.
Uh-huh.
That forces this angle to be 52 minus 12, which is 40.
Uh-huh.
And they tell us that Jeff and Carl are 510 feet apart.
Uh-huh. Now what, good good?
How far is Jeff from the Sasquatch nest? Let's call this side A. We know that sine 40 over A has to equal,
Yeah.
we'll call this one gamma,
Sign gamma.
sine gamma over 500.
I'm good, but you got two unknowns.
Now, if we can only find angle gamma, which we can. Alright. If this angle right here in green, if this is 52, then this is 52. By high school geometry, alternate interior angles.
I hate
This
geometry.
vertical axis is parallel to this vertical axis. That forces this.
That's what you were trying to do earlier, wasn't it?
To be 69 minus 52, which is 17.
Mm.
So this angle is 59 minus 62 equals 17.
Isn't that, no,
Now,
no.
yeah, angle gamma.
59 minus 62 is not 17.
Well, let's do that. Gamma is 180.
69 minus 52.
17.
He had them
Which
backwards.
gives us 123.
These poor kids are gonna be confused.
So sine 40
Y'all want
over
email
A
us?
Yeah.
equals sine of 123 over 510. We can do our cross multiply.
Cross multiply. Who said to do that? Not me.
So A will equal 510 divided by 3.
I just needed confirmation that it was gonna be that hard.
Get good at it.
Cause that's what I was drawing up, and I kept thinking it can't be that hard. I'll seriously.
Alright, so in this list, another, if we drew an axis right here, this would be 75 degrees. And the tower, now they've drawn this tower as like a pointing thing, but I mean, we're gonna treat it like just a straight line. Okay, so this angle would have to be 90 minus 75, which would be 15 degrees. Okay, so this angle is 15 degrees right here, if this is 75. Remember, this is not the scale. That forces this angle to be 165, because 165 plus 15 is 180. Okay, so we got a triangle. Let me draw it bigger now. Not to scale. 11, 165, 154
So we
on
had-
that side.
And 4.
Get this one, 180 minus 11 minus 165.
That's it. That's your triangle.
Excuse me, teachers, any ninth grade student that is interested in having
Oh
their
my
spring
gosh.
picture made, go
26
to the
points.
school library at this time, please.
Yeah, there's 26 questions.
Is there really?
Yes, I looked this
Oh
morning.
my gosh! Thought this would be like a 12 question. There's 1 word problem, 2 word problems, 3 word problems. Oh no!
Oh my god.
Oh,
We can't do those.
yeah.
Just speaking for me, I don't want to speak for the rest.
Oh my gosh!
Alright, that one looks easier. There's a right triangle in there.
At least those are drawn. Forget these, the dang pirate. There's one pirate problem. And of course, it's got Mr. Camp's daughter.
And John.
And John, I bet you they wrote it. You want to bet money? I bet you money that Niblet wrote that question. No way you have Sadie and John.
They just need to.
What a terrible question. Okay, let's leave the test. Please tell me there's none of those on the test.
That's what Alex.
Heron's formula, oblique triangles, law of cosine, practice test. Let's see the real test. That's not a good sign. If the password is Sasquatch, that is not a good sign.
There's only 13 questions?
Uh-huh.
Oh my god.
Oh my god.
That one's not bad. That one's not bad. We can do that one.
Oh my god.
We've not tried that one yet. We don't know. UFO. Okay. There's no pirates.
Steep mountain in.
That's okay. That one's a lot easier to draw. The pirates is what makes that one so hard. The nautical and the east of north. There's none of that. That makes me feel better.
Keep going up, keep going up. There was one that said Carl.
Carl.
Yeah, there was one that had the name
I'm reading about Carl.
Someone's.
That one.
Oh, there he is, a Sasquatch.
Oh my god.
Oh, dang it.
And Jeff.
I gave it to Miss LaRue.
Okay, sounds good.
Uh-huh.
Oh my gosh.
Let me guess, we can't use our calculators?
Yeah, this is a no calculator.
Oh my
test.
god.
We're just screwed, y'all. I'm just kidding.
You got it
Alright,
I'm sorry.
we're gonna skip that problem on the test. That ain't gonna be graded. I ain't grading it.
Can we do it for bonus points?
Yeah, for real.
Because I need them after the last test.
Yeah.
No, I think I can figure it out.
Yeah, if you could, yeah, you do it for bonus. I ain't getting that problem. That's awful. Well, I learned if I'm gonna do 6th period. I'm just playing the videos. I ain't teaching. See what you say. That's awful.
I'll just pretend. I think I meant it. Yeah. And what?
That's awful. That makes me want to look at what the old questions used to be like before they went to my open mail. Let's see if I can still log in, see if I remember. Your account is locked.
It's actually
I'm not gonna.
What? I did it. Yeah, I was like,
Hey, when you get to the Sasquatch problem on the homework, just skip it. Try the other ones, see how they are.
okay, I got to number 4 and it's fine.
Yeah, I mean, all the ones without word problems should be fine. They're exactly the way we talked about it. But now, the word problems, it'll all depend on how hard the setup is. That Sasquatch is as hard of a setup as I've ever seen.
When they take that test and there's that question about it, just email them all and say, hey, I gave y'all points for that question.
Music teacher, any 10th grade student that would love to have their spring picture made, please go to the high school library at this time.
Oh, no, they're at 11.
during ballet. Because we don't need it to be during ballet. I'm sure we're doing that. Is there can I get a couple Are there AP videos tomorrow? I feel like I've seen them.
Sure you want these?
I can come back. It's on for Thursday though, which is today. But he posted them all at the same time. Oh, so those three were for all week?
I know, because they gave me my transcript yesterday. I had a long hair. I was like, whoa.
They gave you what? I was looking for you. Sure, you already went.
Bro, you think I'm going to go get pictures?
You're dressed up.
I was every day.
You don't. You'll have to 12 to 6.
I'm not
Literally,
We were picture of it.
yeah, some of them didn't have the records.
We're wasting time. I try to take some.
So, does the Form C come up with its own questions? And what is that?
Oh, that's right, you're not. Same kind of question, that's the one they make first.
I thought it was
It just seems to be the one that's correct,
I don't know, man.
and that's when they make that one.
You can find a razor phone. Razor where?
y'all's test is posted. You can start.
I'm not coming tomorrow. I said, are you coming tomorrow? I don't think you should come. Jason, are you coming to school tomorrow?
Hopefully, probably make me so.
Are you coming?
Well, it's not
Yes.
actually it's too thin.
I'm not the only one that's sophomore skipping.
It sounds like this sophomore skip day isn't catching on, unfortunately.
Well, that's not their problem. I mean, that's not my problem, it's theirs.
Okay.
How many questions?
26.
Should be the same as the practice test.
Probably have 24.
Yeah, good enough.
Well, I made bad on the practice test.
Practice test is weird.
We haven't extended it.
Yeah, be just like
pictures. Any 11th grade student that would like to have their spring picture made at this time can go to the high school library, please. Any 11th grader who would like to have their spring picture made, go to the library at this time. Thank you. pictures. Any student grades 7 through 11 that would like to have your spring picture made, please go to the high school library at this time. This is the last call. Anybody grades 7 through 11 that would like to have their spring picture made, please go to the high school library at this time. Thank you.
go get softball pictures made?
Can I leave too?
I'll just leave my bag. I don't know that.
pictures. Students, please don't forget that you have FCA this morning upstairs in the science building in the science lab. Mr. DJ Starling is going to be your guest speaker. So everyone, please be sure and attend FCA during break time this morning. Also, I want to wish the softball girls good luck today as they play Sylvania here this afternoon. This is a very important area game. Also, they have a tournament in Murfreesboro, which goes on tomorrow, and we want to wish them good luck in that also. All right, everybody have a good one. Thank you.
What's up, Tony? Hey, if guys run some.
You update that? To what? 29?
29? Really?
Nah. It's 29 in like 15 minutes. But
Do you have a class 7th period? Who's in here 7th period? Because when you get up, you run, I'm gonna need a video. So Austin, you need to be on that. Coots is gonna get up and run out of school. I'm gonna need you to video.
tomorrow.
I'll be at football.
I'm gonna be, he's gonna be right through that wall.
I'm gonna be on the complete opposite side of the school.
That's why there's 2 different ones. You know, there was 2 more? That's one, probably.
Yeah, no, I think I got the last one right. We're just like throwing something out.
Okay. If I get it right, get it bonus points.
Hooray! I got the last one right. Let's go.
It's either 9 to 80 or 10.
Well, should have told us what the right answer was after we turned it in.
That way y'all can tell each other?
10.
No, that way I can know what I did wrong.
Bro, what?
You got the worst class at all. You ever got that good?
I'm okay with what I made.
Dude.
Me too.
Dude.
We're gonna finish it tomorrow. Could we work on it outside class? So I can do it next week.
Can I take my test right now?
Some of the